Okay, here's example 8 with integration by substitution. So this one's going to be a little more difficult and a little more tricky than some of the other ones, than all the other ones we looked at so far, because this is going to take 2 substitutions. So it's not really obvious right away that it takes 2 substitutions. You know, you might suspect maybe it's going to take 2 because, you know, what are we doing? We're taking the integral of 1 over the square root of 1 minus square root of 1 minus x dx. So we have a square root inside of a square root here, kind of like this. So it does look a little messy, so it looks like it's kind of complicated, so we're going to, maybe one substitution is not really going to cut it. So what do we want to let u be? Well, what if we, so remember, we're looking for a function and a constant multiple of its derivative. Nothing really jumps out, right? We can try and let u be, I don't know, if a function and a constant multiple of its derivative aren't really jumping out at us, then we can try and let u be the inside guy. So we have a couple inside guys, right? So 1 over the square root of 1 minus root 1 minus x, so we can let u be that. Okay, that's a good inside guy there. But then if we try du, what are we going to have? Well, the derivative of 1 is just 0, so then we have negative, and then this is 1 minus x to the 1/2. So really what we have is just a nasty chain rule thing going on here. Negative 1/2, and then times negative 1, and then dx, right? So that's really, that's bad. Okay, that's really not a good thing there. Not very helpful to us. It's kind of messy. This doesn't really help us with anything. We have this extra term to worry about. It's just not good for us. Okay, so that's probably not the right u to pick. There are some other things we could do with that, but it's going to be kind of messy. There is a better u we could pick. So what if we let u be, okay, before we pick the right one, let's say, okay, well, if that didn't work, let's try this other inside guy, 1 minus x. Okay, so if we let u be 1 minus x, du is negative dx. Okay, so that means this dx is easy to take care of, but then on the bottom here, this is going to become the square root of 1 minus the square root of u, right? Because 1 minus x is u, so that's sitting inside of a square root, and then we have 1 minus that, okay, 1 minus that inside of another square root. So we still have that on the bottom. We still have this nested square root thing going on. So that's not all that great for us. I think we could do it like that, but it's just going to give us another substitution to make. So, we don't want to make 3 here. So let's try and do 2 steps in 1. And this is a little, so what we're going to do now is we're going to pick the right u, so to speak, and we're going to do a little trick here that sometimes works. It's a trick we can always try. A lot of times it won't make sense to try it because you won't have what you need to try it. But, if you have what you need to try it, there's no harm in trying it. So if it doesn't work out, just try something else. So let's let u be the square root of 1 minus x. Okay, so why are we doing that? Well, the reason is because we want to get rid of the square root here in the substitution. We want to get rid of the nested square root. So that's our goal with this substitution, is to get rid of that nested square root. And then whatever happens later, we'll deal with that. So u is the square root of 1 minus x. So what's du? Du is going to be kind of a mess, right? So it's going to be another chain rule thing with another square root and the bottom floating around like that. So it's not that good for us. But what we could do is this. If u is the square root of 1 minus x, and then let's square both sides. So then u squared equals 1 minus x. Okay. So now let's do differentials here. So it's not really going to be as simple as du, but if we take a differential, remember implicit differentiation way back in Calculus 1? So if we implicitly differentiate with respect to x, that's really what we're doing when we do this. Okay, but so that's going to give us 2u du. Okay, remember that on the left side we're going to get 2u du, and then what happens over here? This just becomes negative dx. Okay. So this was much simpler to work with than doing du equals blah 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 with this dx over here, right? So that's going to be a mess if we try that. But this is much better, much easier to work with. So if we go back over here, and again, the reason we did this is because we want to get rid of the square root here. So we square both sides, and if you have a substitution like this, go ahead and try something like this. And we kind of did something like this in example 7 when we added the constant to both sides to get x in terms of u, and then we made that substitution in the integral. So if you haven't seen example 7, it might be worth checking that out, because there's another example of something like this, but it's a little bit simpler. Anyway, so continuing with this here. So we don't have a negative dx, right? We just have dx. So let's divide both sides by negative 1. So then dividing by negative 1 is the same thing as multiplying by negative 1. So this is just negative 2u du equals dx. So that's great. We have a really nice expression here for dx in terms of du. So let me zoom in a little bit on this. So this says dx. Okay. So dx equals negative 2u du. So if we come back to the integral here, what we're going to see is that dx, so this is just negative 2u du. Okay. Now what happens down here? Well, remember, u is the square root of 1 minus x. So this whole big thing here becomes the square root of 1 minus u. Okay, that's what's on the bottom. So now this integral becomes, okay, so let's zoom back out a little bit. So now the integral becomes integral of, well, let's write it like this, 1 over the square root of 1 minus u, and then dx becomes negative 2u du. Okay, so let's go ahead and rewrite this like this. So first, let's pull out that negative 2 because it's just a constant. So negative 2 integral of u root 1 minus u and then du. Okay. So we got that going on. Now this, we can't really do anything with this. You know, we can't split this up into two fractions or anything. We have the square root kind of ruining things for us. Plus it's just a u on top and 1 minus u on the bottom. So even without the square root, we couldn't do anything anyway. But if we see something like this, this is now really similar to example 7, but it's with division instead of multiplication. So what we have is just a variable u, and then we have a square root of an expression of u. So now what we want to do is make another substitution. Let's say v. Okay, so we're going to now say v equals 1 minus u. Okay, v equals 1 minus u. So what does that mean? That means dv equals negative du, right? dv is negative du. So that's a relatively simple substitution, but that's good because now how's that going to help us? Well, this down here, okay, on the bottom here, that's going to become the square root of v, okay, which is really good. That's great for us. Du, okay, we actually do have a negative du, right? If we want to push this negative sign back in, so we had a negative 2 out here. Let's go ahead and toss that negative sign back in. So that's really negative du. Okay, that's a negative du. So this negative du is going to become dv. Okay, so that's great. We took care of that minus sign out there that we got from here. And then we saw this u floating around. How do we handle the u? Well, same thing we did in example 7. The exact same thing, really. So what we're going to do is say, okay, if v is 1 minus u, then that tells us that, you know, let's add u to both sides. So, and then subtract v from both sides. So this just means that u equals 1 minus v. Okay, so just add u to both sides, subtract v from both sides, just some simple algebra there. So if v is 1 minus u, then that means u is 1 minus v, right? So now we can take this u and replace that with 1 minus v. Okay, so now when we use the second substitution we just did, what are we going to have? We're going to have 2 is still floating around out there. And then what we have is 1 minus v, so this u on top becomes 1 minus v. And then this square root of 1 minus u on the bottom becomes square root of v. So that's the square root of v. And then negative du, remember this minus sign came from the negative 2 here. This just becomes plain old dv. Okay, so that's great. So now this is much better, right? Because now we can split this up into two fractions. So this is going to be 2 times the integral of 1 over, so I'm going to split it up into two fractions and I'm going to write it with fractional exponents. So this is 1 over v to the 1/2 minus v over v to the 1/2 dv. I got to have these parentheses here. Okay, so now let's write it like this. So all we did here was just split it up into two fractions and we are writing it with fractional exponents now. So now this is going to be 2 times the integral of v to the negative 1/2 minus v to the positive 1/2. Okay, so 1 over v to the 1/2, that's v to the negative 1/2. V over v to the 1/2, this is like v to the 2/2 on top. So 2/2 minus 1/2 is 1/2. So that's where all that comes from. Okay. So we're really just integrating this right here, and this is just straight up power rule, right? So we have fractional powers, but it's really not that bad. So kind of running out of room here, so let me just come back up here. Okay, I'm going to come back up here, and then that's going to equal 2. So if I do a power rule thing here, remember add 1 to the exponent. If I take negative 1/2, I add 1, then I get positive 1/2, then I divide by that, right? So if I divide by positive 1/2, then I'm multiplying by positive 2, and then that's going to be v to the 1/2. Okay, and then what about this term here? So let's also do this. Because this 2 out here is going to be multiplied by everything, this 2 right here. So v to the 1/2, if I integrate that, add 1 to the exponent, so that becomes 3/2. So if I divide by 3/2, I'm multiplying by 2/3. And this minus sign comes from here. So then this is going to be v to the 3/2. Okay. And then indefinite integral, so we have a plus c. Okay. Now from here, all we really do is just distribute the 2 and then go back to u. Okay, remember, so v, we made a substitution with u. But then after that, we have to go back to x also. So we got to go all the way back to x. And also, just like in example 7, we could algebraically simplify this a little bit to get a simpler expression, but let's not worry about that with this because it's going to be kind of a mess. So anyway, I am kind of out of room here, so I'm going to erase this bottom part here because we don't really need that anymore. Okay, so starting from here, okay, so we're at this step right here. Now what we have to do is go back to u. So, and also let's distribute the 2. So then that's going to equal, if we distribute the 2, we're going to get 4. Now what's v? v is 1 minus u. So this is 4 times 1 minus u to the 1/2, which is really just square root, so we can also start doing that. And then minus 4/3 times 1 minus u to the 3/2, okay, and then plus c, right? Okay, so that's what's going on there, but now we're not quite done yet, right? We have to go all the way back to x. So u was the square root of 1 minus x. So we do have to go back to x because the original problem was in terms of x. So we have to go all the way back to x. So now this is going to be, don't know if I have enough room, this is going to be 4 times the square root of, so instead of this 1/2 power, let's do the square root. So 1 minus u, what is u? U is the square root of 1 minus x. So we're going to replace this u, okay, we're going to go back to square root of 1 minus x. Okay, so that's what we have here. 1 minus square root of 1 minus x, that's what's going on in here. Now, what do we have? Minus 4/3 times 1 minus u. But remember, u is the square root of 1 minus x. Okay, u is the square root of 1 minus x, so we're going to go back to that. So this u becomes the square root of 1 minus x. And then that's being raised to the 3/2. Okay? And then we have a plus c. So that's our final answer here. So again, just like in example 7, we could simplify this a little more because we have a thing to the 1/2 and a thing to the 3/2, and we also have this common factor of 4. So we can really pull out a 4 times the square root of 1 minus square root of 1 minus x here. So if we want to do that, we can. You know, just I guess for the sake of being thorough and complete, let's go ahead and do that. If you don't care for that, if you don't need to know about that, that's it for example 8. So that's integration by substitution. Okay. So this one was a little trickier, a little more difficult because we had these 2 substitutions to make. And again, what was different here was we did this thing here, which, you know, we kind of did that in example 7. In example 7, it was a lot more like this one here. But, you know, sometimes with substitution problems, you're probably going to have to do something like this. So just remember that you can do that. It is okay. Just be careful. Make sure you account for everything in the integral. Always change into your new variable completely. Okay, you don't want to have the old variable anywhere in there. So here, we changed everything from x to u. So the x's were completely gone. And then here we change everything from u to v. We erased that stuff down here, but then the u's were completely gone. So remember, you know, taking care of this is easy, taking care of that's easy, but then this might be a little tricky. Just remember that you can do something like this. So if v is 1 minus u, then u is 1 minus v, and then you can take care of the u like that. So always go completely into the new variable and get rid of the old variable. And then if it's an indefinite integral, just go all the way back to the original variable like we did here. Okay? So if you want to know, so that's it for example 8. If you want to know about the algebraic simplification of this, like in example 7, let's go ahead and do that. So we don't need any of this anymore. Okay, so this, what do we have? We have some more room up here. 4 times, let's write it with fractional powers again. 1 minus root 1 minus x to the 1/2 minus 4/3 times 1 minus square root of 1 minus x, oops. 1 minus x. So this was to the 3/2, right? So I'm going to write that as to the 1/2 times 1 minus root 1 minus x to the 2/2. And then we just had that plus c. So we'll keep writing that because we do need that. Okay, so now what can we pull out here? So there's a common factor of 4 and this common factor of 1 minus root 1 minus x to the 1/2 to pull out. So let's go ahead and do that. So 4 times 1 minus root 1 minus x to the 1/2. And then what's left over? Well, we just pulled all this out, so all we have left is a 1, okay? So remember, when you factor out like this, you're really just dividing, so if we take this whole thing and divide it by itself, we just get 1 left. So then what's left here? 1/3 times 1 minus root 1 minus x to the 2/2, but 2/2 is just 1, so we just have this to the first power here. So that's all that's going on there, and then plus c. All right, so now let's get a common denominator here. Well, first let's go ahead and do this. This is going to be 4, let's write that with square roots now. 1 minus root 1 minus x. And then what's going on here? We're going to say, so 1 is 3 over 3. And then what we have here is minus. So this minus here, then we'll put the 3 on the bottom here. 1 minus root 1 minus x. Okay, plus c. So kind of a big old mess here. Let's make that easier to read. Okay, so 1 minus 1/3 of all this, that's 3/3 minus all this divided by 3. So then if we simplify a little more, what's going to happen here? So we want to be careful here. When we combine this into one fraction, that's going to be this minus, but it's minus this whole thing right here. So watch out, we do need these parentheses here because it's this minus sign affects everything over here. So when we combine it into one fraction, the minus sign still affects everything. So what we're going to have then is 4 times the square root of 1 minus root 1 minus x times what's inside of here. 3 minus 1 is 2. And then minus negative becomes plus. So we do have that in there, and then all that's still being divided by 3. And then plus c. Okay, so I'm kind of out of room over here, so I'm not going to bother with it, but you know, this dividing by 3 really affects everything over here. So actually, let's go ahead and just write it like that. So here, you know, we're just multiplying a bunch of stuff and then dividing everything by 3. So what we could do, actually there's some room over here, so let's write it like this. So I just want to show all this just in case anybody needs to see all these details. So we have 4 times root 1 minus root 1 minus x times the expression 2 plus root 1 minus x. And then all of that's divided by 3. And then don't forget our plus c. Okay, so that's another way of writing the answer here. So, you know, it's a little more compact. We don't have anything to the 3/2, that's kind of nice, but you know, it's still just a mess. We have square roots inside of square roots, messy expressions like that. But, you know, if you have to simplify it down to this, that's how you do it. You just look for these common factors here. It's kind of tricky because we have the fractional exponents, but it works all exactly the same way. Pull out your common factors, simplify what's left, common denominator, etc., etc. So that's it for example 8 with integration by substitution and messy algebra here.